Okay, so this is our second lesson on the excretory system. I'm just going to finish up the first section of notes today. And then whatever time is left, you can work on your urinary system questions or finish up filling in the notes from yesterday as well. So regulating water reabsorption. So increased water intake is very much adjusted for by increasing urine output. So basically what that means is the more water you are drinking, the more urine you are making, which makes complete sense. Okay, more coming in means more going out. So the kidneys are actually relying on the nervous system. Now the nervous system is something that you're going to learn more in Bio 30. Unfortunately, I can't write on my board, so you get it this way today. So the nervous system and endocrine systems are going to help maintain the balance of water within the body. So the nervous system is really relating to the brain and the nerves, as well as the spinal cord, but it's basically the brain that we're going to be talking about today, as well as the endocrine system. Now, the endocrine system is talking about all of those hormones within our body. So hormones are basically chemical messengers that are going to be released by or regulated by the brain and then released by different glands of your body to do something specific within the body. So, for example, testosterone is going to help promote the production of the secondary sexual characteristics. So, during puberty, certain changes happen to the body as well as in females, but and this can cause different changes within the body, deeper voice, more muscle, hair, etc. So hormones are used to signal the body to do something at a specific time. So the ones that we are going to focus on today in Bio 20 are antidiuretic hormone, which is referred to as or shortened as ADH. And this will come back again in Bio 30. So ADH is going to regulate osmotic pressure in the kidneys. Okay. And its job is to increase water absorption, or technically it should be reabsorption, because absorption would have happened initially in our large intestine. So we would have absorbed the water, and then our kidneys are reabsorbing the water once the waste has been filtered. Osmoreceptors. Now, osmo is referring to osmosis, which then is relating to water. So, osmoreceptors are basically picking up the amount of water within our blood, are located in the hypothalamus. And now, in the hypothalamus, that is actually talking about a small part in the brain. Okay, so really, the nervous system is really what it's saying. Okay, is going to initiate the release of ADH. So once the osmoreceptors realize that there's either too much or too little um, water within the blood, the hypothalamus is like, oh crap, I need to do something about this. So the hypothalamus will release ADH. ADH will then travel to the kidney to tell the kidney to do something. So I broke this down into two kind of different pathways. So the first one, if blood plasma is too concentrated. So basically what that means is you have high osmotic pressure. This means that you have a lot of solute found within your plasma. Now, this means that ADH is going to be released. So if we have, let's see if I can make an arrow. If we have an increase of ADH, what that does is it travels to the kidney and it increases permeability. So by increasing permeability, what that means is the kidney, or technically the nephron, is able to reabsorb more water. So that means we have increased water reabsorption. So when ADH is being released, it tells the nephron to open more doorways so that more water can be reabsorbed into the blood because the blood has too much solutes or it's too concentrated. So this then would mean that you have less water left in the nephron. So less water in the nephron means that you're going to be peeing less, and it also means that you're going to have more concentrated urine. So really what this means is, you know, when you have yellow urine, that is really referring to concentrated urine. So during the nighttime, you typically don't drink a lot. So that means that your blood is going to become very concentrated, okay? And your urine is going to become very yellow, or going to have concentrated urine because your body is not getting the water from outside. So your kidneys are basically being told you need to reabsorb more water. Okay, so ADH is being released by the hypothalamus while you're sleeping, saying, hey, reabsorb water because your body needs it. Reabsorb it now. Okay, and this happens when you have a lot of solute in your plasma, which does happen overnight. Now, if blood plasma is too dilute, so that means the osmotic pressure is low. So too dilute is really talking about you have a lot of water within the blood. So this means that your osmoreceptors are going to say, ooh, we have a lot of water. We don't need any more. We need to get rid of water. So ADH is then not going to be released. Okay, and if it's not being released, okay, then that means that there's no signal being sent to the nephron to tell the nephron to reabsorb water. So if there's no signal saying reabsorb more water, that means that more water is going to stay in the nephron. If it's now in the nephron, that means it's going to drain into the ureter, which will then drain into the bladder, and then the bladder will fill up and fill up a lot quicker. So this means if you have low ADH or no ADH, it's going to decrease the permeability, basically closing all of the doorways to water, which means less water is being reabsorbed, and that means we have dilute urine. So this means you have clear urine. Okay, so during the day, provided you've taken enough water intake or you've intaked enough water, your blood should be full of water because it's traveling through the body. And your kidneys are getting the signal, oh, we have a lot of water. We don't need to worry about reabsorbing any. We can get rid of a lot. So that means that your kidneys are going to basically put more water into the nephron or keep more water in the nephron, which then means your bladder is going to be filling up a lot more and you're going to be getting rid of a lot of water. So this happens when we have a lot of water in your plasma due to drinking a lot of water. So during the daytime. Okay, so that is ADH. The other hormone that we need to talk about today is aldosterone. So this is regulating the salt or the Na positive with regards to our technically water. So the kidneys are actually regulating blood pressure by regulating blood volume. We learned this concept in the circulatory system. So what this means is if you have a high BP, this means that you have a higher blood volume, okay? This means you have more water in plasma or blood, okay? Now, the more water in the plasma, the more blood you have within your blood vessels, that's going to exert a higher pressure on those artery walls, which is what the blood pressure is measuring. How much pressure is on the artery walls? So the more you have in those arteries, the more liquid you have in the artery, the higher the blood pressure is going to be. And we don't want a high blood pressure. High blood pressure is bad. So what that means is our body needs to have a signal that if our blood pressure is high, it does mean that our blood volume is high. So we need to get rid of blood volume. One of the things that our body can do is by releasing, not releasing ADH. Not releasing ADH means that water is going to stay in the kidney, okay, or stay in the nephron, which then means you're going to be peeing more and getting rid of that excess water. Okay, now the other thing that is going to be regulating how much water is in the plasma, in the blood, is aldosterone. Okay, now it works not as directly on water as ADH, but it does it indirectly. And so aldosterone is acting on the nephron to increase sodium reabsorption. So what this means is if you have more aldosterone, that means we have higher Na reabsorption. This means that, I'm going to go back for a second here, your nephron here is getting the signal. Ooh, that's bad, sorry. Let's just maybe do it. There we go. Maybe we'll do it this way. So aldosterone is going to tell the nephron to reabsorb more sodium. So that means out of this proximal tubule, out of this ascending loop, you're going to have more sodium. And remember in our previous video, I said that you have a three for the price of one. So when that sodium goes out, chloride will follow, which then means water will follow because you have now more solutes in your bloodstream. Okay. So even though aldosterone is acting on the sodium component, since the chlorine follows due to a charged attraction and then water follows due to osmosis because there's more solute in the blood than in the nephron, water will want to dilute that. So water, if you have increased aldosterone, it means increased sodium reabsorption, which also then means increased water reabsorption. Okay. So let's actually write that down somewhere because that's really good. Okay, so let's write that here. High aldosterone, if you want to write an arrow up, equals high Na positive reabsorption, which then equals high water reabsorption. Okay. So if there's a decrease in blood pressure, that technically means you have a decrease in blood volume. So now your body is, oh crap, I don't have enough blood pressure, and you need pressure to move things around in your body. Okay, so aldosterone is going to be released by the brain, and aldosterone is then going to travel to the nephron, and it's going to tell the nephron to reabsorb more sodium. By reabsorbing more sodium, that means you're going to have more chloride ions being reabsorbed, which then allows the water to move back into the blood. This then increases blood volume and then increases blood pressure because you do have more volume putting pressure on the artery walls. So aldosterone is actually made in the adrenal glands. Okay, now these are located right above the kidney. So the adrenal glands actually pick up a signal from the brain, and you'll learn that more in detail in Bio 30. But for now, just know that the adrenal glands give off aldosterone. Aldosterone tells the nephrons to reabsorb more sodium, which then reabsorbs more water. And I realized I spelled reabsorb wrong here. Okay, now diuretic substances. A diuretic is a substance that causes you to urinate. So simply saying that if you drink it or consume it, You're going to be peeing more. So this is because diuretics stimulate urine production by decreasing the release of aldosterone and ADH. So a diuretic is going to decrease ADH and aldosterone. If you don't have aldosterone, if you don't have ADH, that means less water is going back into the blood, which then means that you're going to be peeing more because you have to excrete all that water that is now in your nephron. This also means that you're going to have to intake more water because you're going to be feeling thirsty because your blood volume is dropping. Okay, so you're going to start to feel dehydrated if you're consuming a lot of diuretics. So example of diuretic substances are things like alcohol, caffeine, and carbonated drinks. So anything that's carbonated in caffeine, like energy drinks, you're getting a double whammy. You're going to be peeing a lot and you should be drinking a lot of water. And last but not least, the kidneys and blood pH. Blood pH must remain between 7.3 and 7.5, so relatively neutral. So blood pH is maintained by an acid-base buffer system. Now we did talk about a buffer in the very first, or maybe it was the second unit, but a buffer is trying to maintain pH. So what it really means is a buffer is trying to keep a pH buffer for blood is trying to keep the pH of blood at around 7.3, 7.5. Okay, so the most important acid buffer system is maintained by the following equation. So here we have H positive plus HCO3 negative, and then you have this arrow that looks like it's going back and forth. That means that this reaction can proceed forward to the right, or it can proceed backward to the left. Okay, and then this middle one you can see as H2CO3. So this is your carbonic acid, bicarbonate ion, and then your hydrogen ion. And then you have H2O plus CO2. So this looks very similar to something we saw in our respiratory system. So in our respiratory system, if you think back, you had the CO2 and the water coming into the blood that combines to make carbonic acid, which is bad because that decreases pH, right? And then it will dissociate into the bicarbonate ion and then the hydrogen ion. So if your reaction is maintained at this H2O-CO2 component, this means that your pH is going to be increasing or becoming more basic. If you're staying at this side of the equation and you're having more hydrogen ions within the blood, okay, because there's only a certain amount of red blood cells that can carry this H, and if they stay in the blood, that means that your blood is going to be more acidic, okay, so you're going to drop pH. So if our blood is moving toward a pH of, say, 9, and this is extreme, but if we have a pH of 9, that means our blood is too basic. So then our brain is going to send a signal to push our reaction this way because we want to add acid to our blood. If we add acid to our blood, that means your pH is going to go from a 9 to an 8 to a 7.5 to a 7.4, and then your brain's like, oh, we're good. We can calm down now. The same thing would happen vice versa if you had a pH of, say, I don't know, 4. So that's extremely acidic. So then you want your reaction to go to the right so that you can add base to your blood to try to bring up your pH. So I kind of broke it down into 3 things that can happen with regards to the blood, okay, of how we can make the reaction more acidic or more basic. So buffering capacity of the blood. This is what I just talked about with regards to pushing the reaction to the right versus the left. So if the blood is too acidic, a pH of, I think I used 4, this pushes the reaction to the right. Okay, so then that means we're trying to add more base. So you're going to add more H2O, more CO2 to the blood, which is then going to increase your pH in the blood from that 4, for example, to back to 7.4. If the blood is too basic, we're going to push the reaction to the right, which then is going to add acid to the blood, which is then going to help decrease the pH. So I went from the 9 to the 8 to the 7.5, etc. So that's 1. 2, breathing rate. So if the blood is too acidic, what that means is we need to add more base, right? We need to be on this side of the reaction. Okay, so accompanied with trying to bring this side of the reaction about, we have to increase our breathing rate. Okay, because what this means is you're going to generate more carbon dioxide quickly. Okay, so this means that you're bringing in more oxygen to the body, which means your cells are going to do more cellular respiration. Doing more cellular respiration means you're going to make more CO2. Okay, so when you're increasing your breathing rate, that typically means that your cells are doing more work. You're running, for example, you're pushing weight, um, you're, I don't know, nervous, upset, etc. Okay, so breathing rate will, yes, bring in more O2, but it's also generating more CO2. If the blood is more basic, then it's going to decrease our breathing rate, which means that you're pushing the reaction to the left, which means you're going to generate more hydrogen ions. Now, how do we generate more hydrogen ions? Okay, so more hydrogen ions could be generated by keeping less of those hydrogen ions within the red blood cell and more staying in the plasma. The other thing that can generate more hydrogen ions is the kidney is responsible for reabsorbing a lot of materials. I didn't really talk about hydrogen or the bicarbonate ion, but I focused on the sodium and the chloride. But the hydrogen and the bicarbonate ion are also reabsorbed and excreted by the kidney. So that being said, if the blood is too acidic, okay, so if we're over on this side, do we need more hydrogen and more bicarbonate? No, we need to draw the reaction this way. So we need to get rid of some of this. So what this means is, and more specifically the hydrogen, because we are more acidic, whereas if we have only this, it's more basic. So this means hydrogen ions will be excreted. So that means your nephron is getting a signal to keep more of the hydrogen ions in the nephron and pee them out. And then the bicarbonate ions are going to be staying within the blood, trying to bring this reaction to a more basic component. If the blood is too basic, instead of keeping the hydrogen ions within the nephron, we want to reabsorb them. So here it's saying not excreted. So that means that we want to reabsorb them. And the bicarbonate ion will also not be reabsorbed so that it can bring the reaction back to the acidic component here. So it's going to draw this reaction back here so that we can create more of these. Urine in itself is usually acidic because we do generate a lot of our hydrogen ions. So we do want our body to excrete a lot of those hydrogen ions as well as those sodium ions, etc. So the balance of a substance, so homeostasis, in our urine depends on a number of factors like diet, physical activity, stress, and fatigue. Our body must maintain that homeostasis, which is why we have our kidneys working, our breathing rate, and that buffering capacity of the blood happening all at the same time so that we can maintain that homeostasis. So some but not all factors. So glucose in urine. So if you find glucose in the urine, what it really means is you ate a crap ton of sugar, okay? Or it could also mean you do have diabetes because insulin is not working properly, and insulin you'll learn more in detail in Bio 30. But if your body has too much sugar in the blood, you have to get rid of it. The only place you can get rid of it is with your kidneys. So instead of your kidneys reabsorbing the glucose, it's going to keep the glucose in the urine. Now, the same thing with your proteins. If you have proteins in the urine, you've had a vigorous workout, so your body is breaking down some of the proteins. So you're gonna pee out some proteins. And then ketones, if you have ketones within your blood, you're also going to have low carbohydrates within the blood. You're gonna learn more about this in Bio 30. This is all you need to know for Bio 20. So all of these factors are going to be taken into account by your doctor when they're actually analyzing the urine to look for indicators of diseases such as diabetes, etc. So it's important that you tell your doctor, communicate with your doctor everything that has happened throughout the day or previous day so that they can make an accurate decision of whether or not you have such disease. So for example, the glucose in the urine. Okay, yes, it can be a signal for diabetes, but it also could mean that you just ate a crap ton of sugar. Okay, so make sure you communicate with your doctor. That is the end of today's lesson. Now, posted on Classroom is urinary system questions. I know it says they're posted here. There's some right here, urinary structures you can practice. Okay, and here it says the urinary system questions. We're not going to use them here. They're the same ones that are on Classroom. Please complete them in Classroom. Thank you.